So this is a follow-up to a video I did almost 2 weeks ago, and if you've just stumbled across this or haven't seen that other one, I highly recommend that you watch that first before continuing with this one. So it'll only take you 3 minutes, it's a short video, and there's a link to it in the description below. So yeah, go ahead and do that. I'll wait. You're back? Good. Now, in that video I demonstrated that this Pdp1134 had an Easter egg, something that appeared in the display, something unusual, that happened if you typed in a certain combination of keys. And I'll just do a quick recap of the Easter egg thing. Turn it on. It's already been told to do that when it starts up. There's the Easter egg. And when that finishes, does that scrolls 3 times and then flashes. It's then back to normal operation, and about the only thing you can do with only that console board installed is the switch register test, where you can go put in a number, load switch register, put in the switch register address, load it, examine it, and there comes the number back. That's about all you can do. Some people thought that was some sort of an April Fool's joke that I was trying to pull. So this video, being Easter Sunday, it seems like a good time to look for Easter eggs. Easter egg hunt on Easter Sunday. So let's have a closer look at this, and you can see that there's no funny buggers going on. Underneath there, there's nothing underneath the interface board there. So now I'll take off the console and we'll see that there's nothing strange happening there either. Just 4 screws for that. Just rest it on this so that the console can come off easily. And so, looking at the wiring in here, you'll see that there's nothing strange going on. Hang on. That doesn't look right. What the hell is that? I'll pull these 2 leads off. What the hell is this? Could this be my Easter egg? I'll get some scissors and cut that open. Yeah, definitely non-standard, this thing. Some gizmo. Right. I wonder if that's got something to do with the Easter eggs. So, to those people who thought that this thing could really do what I showed it doing, April Fool, gotcha, sucked in. Admittedly, people didn't fall for it very much. Most of them realised it was a joke. Although I think even 1 or 2 experts were unsure for a while. The objections that I expected to arise immediately did come along pretty quickly. Namely that unless you've got core memory installed in here, there's no such thing as non-volatile memory in there. So there's no way known that it could remember after it was powered off that it has to produce the Easter egg when it's turned on again. And secondly, the display there, the 7-segment display, is driven from I'll show you on the schematic. Now I hope the interference patterns from the LCD and the camera aren't too bad. I think they're bearable. Yeah, the 6 display digits, the segment lines of them, the 7 segments, are driven by this E6, which is a 7447A BCD to 7-segment decoder. And if we look at the data sheet for that, it has 4 input lines, so A, B, C, D, and so there's only 16 possible combinations, and they're the possible results, and there's no P's, D's, underscores or dashes there. And in fact, back at the schematic, we can see that the D input is tied low, so the only combinations that can come out of this are for the 8 possible combinations on those 3 remaining lines, which are 0 to 7, 8 possible octal digits. So there's no way known this thing can produce those other characters that we saw in the Easter egg. And someone pointed out that, yeah, well, that's possible by, if this thing's open collector, so it works by pulling these resistors low, and if we can disable that from doing it, then we can use something else to pull these lines low to anything we like, and that's what's going on. And the easy way to do that is this BIRB, burb. It's held high by this resistor, but if you pull that low, it disables this chip, so it will never try and pull any of these segment lines low. So by making that burb line low, then we can set these low as we choose. And if we look at the layout of the console board, there's the displays, and there's that E6. And these resistors are these 7 outputs from the decoder going to the display modules. And it just so happens that those are spaced at 1/10 of an inch intervals. And then there's another 1/10 of an inch. Next 1/10 of an inch just happens to take us to a pin on the chip. 2 more 1/10 of an inch gets us to the opposite pin on that chip. And that opposite pin just happens to be that burb input. So if we connect a 12-pin connector right across there, we capture the 7 inputs to the display modules and that burb pin. Now it's not precisely 1/10 of an inch line up, but it's very close, and it's easy to put a connector on there, and that's what's happened. There they are. There's the 7 resistors there. There's the 2 lines from the chip, and the final one there goes to the burb pin. There's a few that are unused. Now this doesn't involve removing any parts from the board or cutting any traces. It's simply just this thing soldered onto the backs of the pads on the back of the board, and I've added some hot melt glue to make the thing solid, but that's easily removed. Some heat and isopropyl alcohol will get rid of the glue, and then it can be easily dissolved. So, and those 12 lines go to this thing, which I call the interceptor. Obviously it's got an Arduino Nano on it, and I call it the interceptor because it intercepts the signals coming from the M7859 board and going to the console. In fact, it only intercepts 4 of them. Most of them pass straight through, and there's a few bodges. Development. These are 2 open collector buffers, which are used to drive those lines low or high as required. Open collector outputs, so a wired OR with the output of the 7447A. These 2 other chips are shift registers, a parallel in serial out and serial in parallel out. That just drives these chips. Pretty straightforward. So that's how it was done. So why did I go to the trouble making all this? Was it just for an April Fool's joke, or to get some likes on a YouTube video? Well, if that was the reason, it would be pretty disappointing. I only got about 12 likes, and there's a fair bit of effort there. And yeah, it is a bit disappointing. I thought the joke was pretty well done and the technology's reasonably clever. But no, that's not the reason I did this. In fact, the functionality I was trying to achieve by making this thing wasn't even demonstrated in the Easter egg video. The ability to change the output of the display was just an add-on. Only took a few more chips to get that, and it could be useful, but that's not what I really did it for. What I really did it for is what I'm about to show you. Right, what I was trying to get happening with this contraption is this. Watch the display here when I press that button. This PC is typing keystrokes into here. It's doing it 1 in a second. This is just a switch register test, so it's now putting in the switch register address 77570, load address, examine, back comes the number it put in. Now it's doing it at 2 characters per second, or 2 keystrokes per second. Now 4 keystrokes per second, and now it's doing 8 keystrokes per second, and it's doing it a few times just to see that it's able to do it. Theoretically, it could go a bit faster than that, maybe 16 times, maybe not, borderline. This multiplex display cycle, which works for both the display and for the keypad scanning, happens about 45 times a second. So I presume the M7859 wants to debounce, so it wants to see a key pressed for 2, maybe 3 scan cycles, and so perhaps the best you can get is 15 characters a second, 3 scan cycles. But it does enable a PC to control this. Now, there are other ways of doing that. There's the Pdp11 GUI program. I don't know much about these, I haven't looked at them. But there's also another board you can put in the PDP, which contains a whole lot of proms with bootloader programs for various devices. And included in that is a console emulation, so you can do what we just did there through an asynchronous port, either through that console emulation program in the ROMs, or using PDP GUI. But for those things to work, I'm presuming, because I haven't looked into these deeply, but I presume for that to work, you will need not only a working console and console interface, you'll also need a working CPU, memory, bootloader board, and asynchronous communications board. So that's a whole lot of stuff that's got to be happening before you can use a computer to drive your PDP, which is fine if your PDP works. But what if you're trying to do a lot of this console stuff while working on those CPU, async boards, memory, for testing those things? You can't do that through other means that use the async board, but you can do it with this. So that's why I did it, to be able to automate this stuff. Now, there's a bit more to it than that. Let's have a look. So what was happening when we pressed that do stuff button was simply sending a command string to here, and that string looks something like this. C for the clear button, then the value to load into the switch register, 1, 3, 5, 2, 4, 6. Then R means load switch register, that button. Then enter the address, 7570. Load address is done with L, and then examine is E. And if we send that, this is still running at 8 characters a second, and it worked just from that. Now, you could write a program with a whole bunch of scripts to do whatever you want, even enter bootloaders, or even enter entire programs. I'm not sure how tedious that would get if this can't be made to work any faster, but yeah, it's a way of doing stuff. Now, we can get even cuter than that by doing this. Now we have a virtual Pdp11, and we can type stuff in like before. 2, 3, 4, 5, 6. This is a bit tedious with a mouse. I haven't made it. I should make it so you can just type in the characters here, the same as you did as were entered in that script, but I haven't done that yet. Load switch register now. 777570. Load address, and then press examine, and that comes our number. Not only goes from there to there, it goes backwards as well. So if I go clear, see it highlights there that 1, 2, 3, 4, 5, 6, that should go out. Development, still working on it. Ding, that should be out. That's pretty cute, isn't it? And we can combine the two, so we'll run this thing again. Now it's back to 1 character a second, and we'll zoom in on the virtual console. So isn't that cute? Now, this interface contraption is intended to be bolted into the space between the console and the card area. There's an ample room for it in there, so I'm thinking of getting proper circuit boards made once I've finalised the design, and maybe make a project of it if there's some interest. So let me know what you think, and I hope you enjoyed that. On the real PDP, I'm pressing the control to 1. You sort of saw something happening there. That stuff's not working real well, but it should be in Easter egg mode now. Because of electronics at the moment, I can't power off the PDP, but I can press reset here, which will restart the Arduino, which will make the Easter eggs appear. So there you have it. So I'm thinking, if there's interest in this thing, I can make a project out of it, proper circuit boards and all that. Maybe a bit of collaboration with others if there's any ideas. So let me know what you think. If you enjoyed this, please give it a like. That's always nice to see, and maybe subscribe, and we'll catch you later.